As you gaze into the vastness of space and witness the twinkling dance of billions of stars, each one seems to raise a silent question that has plagued humanity for generations. Are we alone in the cosmos? Now, a groundbreaking instrument has been launched into orbit, the James Webb Space Telescope. This technological marvel works like a powerful magnifying glass, offering unprecedented clarity in revealing the intricate details of distant planets. Recently, the JWST set its sights on a remarkable target, K2-18b, an enigmatic exoplanet. Initial observations of K2-18b sparked a wave of excitement within the scientific community. This celestial body was no ordinary planet. Not only did K2-18b exhibit the presence of water vapor, a potential indicator of habitability, but it also contained a molecule that aroused deep intrigue, a molecule often associated with biological processes on Earth. Could this be the momentous revelation humanity was waiting for? The confirmation of extraterrestrial life? In this video, we'll delve deeper into K2-18b, exploring the scientific challenges and far-reaching implications that could reshape our understanding of the universe. Let's embark on an investigation of the first tangible image of K2-18b. Located 120 light-years away, K2-18b is a super-Earth within its solar system, distinguished by its classification as a sub-Neptune, unlike anything in our own cosmic backyard. This planet is larger than Earth but smaller than Neptune, defying conventional planetary categories. This unique status presents a considerable challenge for scientists trying to unravel the mysteries of K2-18b. While rocky planets like Earth and Mars serve as benchmarks for hypothesis building, distant gas giants like Jupiter and Saturn offer tentative comparisons for understanding this distant world. However, sub-Neptunes that have no familiar counterparts in our cosmic neighborhood remain an enigma. The data available so far suggest some fascinating theories. For example, K2-18b orbits in the habitable zone of its host star, a red dwarf called K2-18, raising the possibility that its surface may harbor liquid water similar to Earth's oceans. It is crucial to note that K2-18b's orbit around its host star is much closer than Earth's orbit around the Sun. While 1 astronomical unit, AU, represents the average distance between Earth and the Sun, K2-18b is only 18 cents away from its star, even closer than Mercury is to the Sun. This proximity means that a year on K2-18b lasts only 13 Earth days. Fortunately, K2-18b's host star, K2-18, is a red dwarf, which means it emits less heat than our Sun. This prevents K2-18b's surface from being completely scorched, unlike what would happen if it were so close to a star like our Sun. In fact, K2-18b's lower luminosity has turned out to be a benefit, as it has allowed signs of vaporized water to be detected in the planet's atmosphere, a groundbreaking discovery that suggests the presence of biological signatures similar to those we would find on Earth. This discovery further increases the scientific interest in this exoplanet. The fact that methane decomposes rapidly under solar radiation added even more excitement. The JWST also detected carbon dioxide, a more common atmospheric component. However, the combined discovery of methane and CO2 was overshadowed by the detection of dimethyl sulfide, DMS. Unlike methane, DMS is not commonly found in Earth's natural environment. It is a molecule produced exclusively by biological processes. This finding is particularly intriguing given that K2-18b orbits a red dwarf star known for its intense radiation and is generally considered inhospitable to life. However, K2-18b defied these expectations. It is crucial because on Earth, DMS is only produced by life, mainly by microorganisms in the oceans. It is known to be a reliable biomarker if detected in a planetary environment, as predicted. It is therefore crucial that the planet receives a similar level of radiation and resides within the habitable zone of its star system, where temperatures are neither too hot nor too cold for liquid water to exist. Provided there is a stable atmosphere, K2-18b could have temperatures comparable to those of Earth, although with an atmosphere dominated by hydrogen, which would make its oceans slightly warmer than those of our planet. The proximity between the star and the planet is such that they could be considered close companions, and this closeness prevents surface water from evaporating. This detail is of great importance, especially in light of recent research suggesting that surface water could be a distinguishing feature of exoplanets like K2-18b. Stay tuned, because we will soon go into revealing details about the mystery of the Hyanic world. In 2021, astrophysicist Niku Madhusudhan, known for his possible discovery of DMS in space, proposed a new category of exoplanet. In a fascinating paper published in the Journal of Astrophysics, subneptunes cradled beneath a thick, hydrogen-rich atmosphere were introduced. Madhusudhan has chosen to call this class Hyanic, a name that suggests an unknown and mysterious nature. If these water giants exist, they will be radically different from anything we have ever seen before. Although they could be up to 10 times the mass of Earth and twice its radius, they won't be scorching infernos of steam. Yes, they will be incredibly hot, with temperatures approaching 200 degrees Celsius, but what would define them, however, would be an astonishing feature: a colossal layer of water that could represent up to 90% of the planet's mass. This vast ocean, at least in theory, could harbor the potential ingredients for basic microbial life. These dense atmospheres would trap heat from the star, allowing liquid water to exist over a much wider range of distances from the star compared to rocky planets like Earth. Subneptunes are relatively common, and Hyanic worlds benefit from this extended habitable zone. This makes them ideal targets in the search for life beyond our own planet, as larger planets are easier to detect from far distances, making them prime candidates for our telescope. Dr. Madhusudhan's team uses the revolutionary James Webb Space Telescope to observe K2-18b, a possible alien world. This tool could be crucial in our search for extraterrestrial life. But there is a challenge. Even with advanced technology like the James Webb, detecting these ocean worlds is a difficult task. The key to unlocking the secrets of K2-18b lies in a meticulously planned observation, requiring a total of 5 hours divided into 2 separate observing periods. K2-18b played a crucial role in a celestial event known as a transit, during which a potentially similar world passes directly between us and its parent star. James Webb captured the light passing through K2-18b's atmosphere during this transit. The beauty of this technique lies in the unique fingerprint that starlight carries, like a universal language that reveals the elemental composition of the material with which it interacts. By separating the light into its individual wavelengths, similar to how a prism breaks down white light into a spectrum, scientists can analyze this fingerprint to identify the molecules present in the planet's atmosphere. If specific wavelengths are missing from the final spectrum, it becomes an important clue to understanding the chemical composition of the distant world, allowing researchers to form a complete picture of this environment. Let me know what you think in the comments box. If you liked the video, remember to like and subscribe. Share it to reach more people. Thank you so much for watching, and I'll be seeing you in the next video.